projects. In this video, we are going to explain about a project titled A Machine Learning Framework for Biometric Authentication using Electrocardiogram. Now coming to the introduction part, advancements in the field of biometric authentication have paved the way for innovative and secure identity verification methods. Among these, electrocardiogram, that is ECG signals, have emerged as a promising biometric feature due to their uniqueness and resilience to forgery. This paper introduces a comprehensive machine learning framework tailored for biometric Python projects utilizing ECG signals as a primary biometric modality. Traditional biometric modalities such as fingerprints and iris recognition have been widely adopted, but the need for continuous advancement in security has led researchers to explore new possibilities. ECG signals generated by the electrical activity of the heart have proven to be an effective biometric identifier with inherent advantages like non-invasiveness and continuous generation. So our main objective for this project is to identify and select appropriate machine learning algorithms that can handle ECG data and classify individuals with high accuracy. The framework aims to train the chosen models using the extracted ECG features and evaluate their performance using appropriate metrics. By implementing the framework in Python, the objective is to ensure accessibility, ease of use, and potential for further customization. Additionally, the framework strives to be robust against potential attacks and capable of handling variations in ECG signals due to their different recording conditions or psychological changes. The objective of the machine learning framework for biometric Python projects using electrocardiogram is to develop a comprehensive and efficient system for biometric authentication using ECG signals. Now coming to the requirements, we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, first we have operating system, that is Windows only is required. Processor i5 and above is required. Minimum 4 GB of RAM is required. Hard disk 20 GB and above. Coming to the software requirements, Python IDEL, that is 3.7 version is required. Now coming to the methodology part, first we have upload ECG dataset. This step involves acquiring an electrocardiogram dataset which contains a collection of ECG signals recorded from individuals. The dataset may include various classes of ECG signals representing different heart conditions or psychological states. Uploading the dataset is the initial step in the process, providing the necessary data for subsequent analysis and model training. Second, dataset pre-processing, Fourier and flipping. Before training the machine learning algorithms, the ECG dataset undergoes pre-processing to prepare it for analysis. The pre-processing steps may include applying the Fourier transform to extract frequency domain information from the ECG signals, which can be useful in identifying specific patterns or abnormalities. Additionally, flipping or augmenting the dataset by horizontally or vertically, mirroring the ECG signals can help increase the dataset size and improve model generation. Third, train SVM algorithm. Support vector machine, that is SVM, is a supervised machine learning algorithm used for classification tasks. In this step, the pre-processed ECG dataset is used to train an SVM model. The algorithm learns from the labeled dataset, finding an optimal hyperplane that best separates different classes of ECG signals. SVM is known for its ability to handle high-dimensional data and can be effective in classifying ECG signals into various heart conditions or other categories. Fourth, train decision tree algorithm. Decision tree is another supervised learning algorithm used for classification and regression tasks. In this step, the pre-processed ECG dataset is used to train a decision tree model. The algorithm recursively splits the data based on the most significant features, creating a tree-like structure that aids in classifying ECG signals into different classes. Fifth, train ANN algorithm. Artificial neural network, that is ANN, is a deep learning algorithm inspired by the human brain's neural network. In this step, the pre-processed ECG dataset is used to train an ANN model. The model consists of multiple layers of interconnected neurons, enabling it to learn complex representations and patterns from the ECG data. ANN can be highly effective in capturing intricate relationships in ECG signals and providing accurate classifications. Sixth, train CNN algorithm. Convolutional neural network, that is CNN, is a specialized type of ANN commonly used for image and signal processing tasks. In this step, the pre-processed ECG dataset is used to train a CNN model. The architecture of CNNs includes convolutional layers that enable the model to automatically learn facial patterns and features from the ECG signal. CNNs are well suited for analyzing sequential data like ECG signals and can achieve state-of-the-art performance in various classification tasks. 7. Extension hybrid CNN algorithm. The term extension hybrid CNN algorithm likely refers to an advanced version of the CNN algorithm used for ECG analysis. It could incorporate additional techniques for modifications to the traditional CNN architecture to improve its performance on the task. The extension might include using other types of neural network layers, combining CNN with other algorithms, or integrating some domain-specific knowledge. 8. Upload ECG test data and authenticate user. In this step, ECG test data from new or unseen individuals is uploaded to evaluate the trained model's performance. The purpose of this step is to assess how well the algorithms generalize to new data and whether they can accurately classify ECG signals from unknown users. Additionally, it mentions authenticate user, suggesting that the ECG signals could be used as a form of biometric authentication, verifying the identity of a user based on their unique heart signal. 9. All algorithms comparison graph. After training and testing all the mentioned algorithms, that is SVM, decision tree, ANN, CNN, and potentially the extension hybrid CNN algorithm, their performance is likely evaluated on the same test dataset. The comparison graph could show various metrics such as accuracy, precision, recall, F1 score, or area under the receiver operating characteristic curve, that is AUC and ROC. This graph is essential to understand which algorithm performs best for the ECG signal classification task and provides insights into which approach is the most suitable for the given application. Now coming to the execution part. To execute the project, first we need to open the code folder. Here there are two folders, that are ECG dataset and test ECG. So in ECG dataset folder, we have some text files, name as with a person and some number. This folder, that is test ECG. In this also we have some text files for testing the dataset. Here ECG is the main code of the Python file which contains a Python script in it. And here this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. Here this is the graphical user interface. With this we are interacting with the program. Now click on upload ECG dataset button to upload dataset. Now select ECG dataset and click on select folder button to load dataset. Here in this screen, dataset loaded. Now click on data pre-processing Fourier and flipping button to read data and clean the dataset. Here in this screen, dataset contains 20% ECG record and each record contains 5000 values. Now click on train SVM algorithm button to train SVM with this dataset. So here in this screen, You can see SVM is trained and we got accuracy as 0.50%. Now click on Train Decision Tree Algorithm button to get decision tree model. Here on this screen, we got 0.60% accuracy of the decision tree. Now click on Train ANN Algorithm button to train ANN with above dataset. So here we got accuracy as 0.70%. Now we got MSE and MAE for each algorithm. Now click on Train CNN Algorithm button to train SVM with the above dataset. So here CNN we got 0.90% accuracy. Now click on Extension Hybrid CNN Algorithm. Here you can see the accuracy as 0.95%. Now click on Upload ECG test data and authenticate user button to upload test ECG and then application identify person from test data. So here I am uploading test data to text file. Here on this screen, selecting and uploading test data to .text file, and then after clicking on the open button to get the result over here. Here you can see person ID is authenticated or identified as person ID 9. And similarly you can upload for any other test dataset and authenticate user. Now click on All Algorithms Comparison Graph button to get accuracy graph of all the algorithms over here. Coming to the conclusion part. In conclusion, the machine learning framework for biometric authentication using electrocardiogram data proves to be a highly accurate, user-friendly and secure mode for identifying and verifying individuals. The model's ability to achieve low false acceptance and false rejection rate, coupled with its resilience against spoofing attempts, showcases its potential for widespread adoption in various applications. The framework's scalability and generalization capabilities further enhance its practicality, making it a promising solution for robust and efficient biometric authentication systems, ensuring both convenience and security for users. Moreover, the emphasis on robustness and security safeguards the framework against potential attacks and ensures its resilience under various recording conditions and psychological changes. The successful implementation and validation of the framework using real-world ECG datasets solidify its practicality and potential for broader adoption.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.